Welcome to the 2007 NSF RU presentation.
Okay, our overall goal is to go from a scent to a robot behavior. A major part of this is identification of scents. This is achieved through pattern recognition algorithms, which can be used to evaluate quality. A major part of it is the pattern recognition algorithms, which are used for evaluating the quality, determining concentration or mixtures, mimicking human perception, or performing substance identification. I decided to concentrate on substance identification for my project goal. In my research, I found that e-noses had to be specifically trained for all chemicals that they encountered. In other words, if an e-nose finds an unknown chemical, it can either classify it as a mixture, or it can sometimes group it in the functional groups, but it doesn't actually even guess as to what the chemical actually is. My goal is to integrate a pattern recognition algorithm with an external database, so the algorithm can extrapolate the identity of the unknown based on the chemical identity of its nearest neighbors. In this way, programs or robots can learn and adapt to new scents. So as I said, I want to go from a scent to an identification, which can be used for robots. My methods were, first of all, I programmed entirely in MATLAB and utilized PCA as a dimensionality reduction and pre-processing technique, and created a simplified database as my external database. I also used a hybridized cluster analysis. My present progress is that I've created the algorithms and I'm now working on testing, and also if there's any extensions such as behavior, I may also extend in that direction so that we can go to a robot behavior. So my algorithm works like this. Odors are input to the e-nose, which produces an array of an array of just resistance, the changes in resistance, which I used in PCA analysis. When it comes in with the stuff that I'm testing, it has 32 dimensions, which is a little bit hard to analyze it, and especially hard to visualize. So I reduce it to 3 dimensions in my PCA analysis, and also get rid of a lot of the excess noise. The next step is cluster analysis, in which I look at each of the groups that you can see in PCA. We can see that they're in clusters, but computers can't quite see that off the top of their head. So the cluster analysis actually works to split those into clusters that the computer can recognize. That's all in this training stage. In the operational stage, an unknown odor is identified. We start out with the unknown odor, which goes through to the e-nose, and then is scaled with the PCA matrices that we found in PCA analysis. Cluster analysis is next performed, in that cluster analysis, it looks at the nearest neighbors and calculates the probability using something called Chebyshev's inequality to determine whether or not, or how likely it is that the new unknown actually exists in one of the other clusters. Using that data, an external database is accessed to find similarities in the substructures and searched for the most likely match according to those substructures as to what this unknown chemical is. Once that's found, it performs and discovers the probabilistic identification, and this can then be used in a robot setting to determine a particular behavior. After that, you can start all over again. So as I mentioned previously, we want to go from the scent to a robot behavior in the same way that flies do. An important part of this process is understanding the fly's odor-seeking behavior. And Chris, I will now introduce Chris, who will explain to us this process.